Alright guys, your help video for today's classwork assignment, Unit 3, Multiple Choice. Let's go ahead and take a look at question 1 here. They tell me that m of x is equal to a function. They tell me that f is a differentiable function, and they want us to be finding this. Now this is what we call a composite function, and the way you find the derivative of a composite function is by doing the chain rule. Alright? And so we have an outside function, which is the f here. And then we have an inside function, which is the m. So when you do the chain rule, you do the derivative of the outside. Multiplied by the derivative of the inside. Okay? Now, we know what m of x is. M of x is tangent of x, so I'm just going to replace m of x with tangent of x. And then here for m prime, I'm just going to do the derivative of tangent, which is secant squared. And that's the most we can do because they don't tell us what f is, and so that's how we'll leave it. All right, let's go ahead and take a look at number 2. So in question 2, I'm telling you that in order to apply the chain rule, you need to have a composite function. That is, you should have a function plugged into another function. And so here are some examples. Now, in this case, a lot of times a composite function has an inside function where you have parentheses. But exponential functions are the exception to that. When you have an exponential function, the inside function is the exponent itself. And so these are all examples of situations where you apply the chain rule. So just look at the options that they give you there on question 2 and look which ones would have an inside function. Okay, on question 3 we have another opportunity to apply the chain rule. It looks like we have an outside function and an inside function. The inside function is kind of obvious here. There's that. And then we have the outside function, which is the 5 times the f minus the 8. So let's go ahead and do the derivative of the outside first. So the derivative of the outside, well, we have a 5 here, which is a constant multiple, and so those just typically stay. And then we have the f there, which is f prime of 4x squared. And then we have the 8, which is just a constant, so it goes away. Okay. Now we have to multiply that by the derivative of the inside, which is the 4x squared, so that would be 8x. And who knows, maybe they'll want us to simplify it, so in that case we could put these together and get a final answer of 40x f prime of 4x squared. All right. Question 4. What is the slope of the line tangent to this curve at this point? As you guys know, in order to find the slope of a curve, you need to find its derivative, and then you're going to plug in the numbers that they give you. And so we need to find the derivative of this. Now this is an implicit function. So how do you find the derivative of an implicit function? Well, you have to apply the chain rule, but it's going to look a little bit different, but it really is the chain rule. Basically, anytime this variable down here matches the variables in the equation, you're just going to take the derivative like normal. But if that variable doesn't match, like right here, for instance, that's really a composite function. You're going to have to multiply it by the derivative of the y as well, so you get a y prime added to it. Okay, so let's go ahead and see what I mean by that. Let's do some of the easy ones first. So the derivative of x cubed. Well, since the x's match, you just take the derivative like normal. So that'll be 3x squared. I'm going to skip this one because that one's going to be challenging. We'll come back to that at the end. But let's go to the next one. I'll just put a plus and a big old blank there for that one we're skipping. Now let's do this one here. The derivative of 2y, it's just, or y squared, that's going to be 2y, right? But since it's a y instead of an x, you get a y prime as a result. And then finally you have the negative 4 there, which just becomes 0. All right. Now let's go ahead and do the derivative of this part right here. Now the reason why I wanted to skip on that one is because that's going to be a product rule. Okay. We have two things. We have the negative 4x squared. That's the first part. And then we have the y cubed. Okay. And so whenever you have the product rule, it looks something like this. So let's go ahead and get started on it here. So with the product rule, you do the derivative of this guy, which would be negative 8x, times this guy, which is y cubed, and then plus, and then we're going to go back to the 4x squared, but this time it's not going to be a derivative, it's just normal. And then in this last slot here, we're going to put the derivative of the y cubed, which is 3x squared. I'm sorry, 3y squared. But remember, we're taking the derivative of something with a y in it, so we need to put a y prime there. Okay. Now I'm going to rewrite this in a little bit more of a simplified form now. So we have 3x squared minus 8xy cubed minus 4x squared y prime plus 2y prime. Okay, so that's the first step. If you want to find the slope of a line tangent to a curve, you've got to find its derivative, and we did that. It's just that the derivative was a little more complicated because it's an implicit function. Now what we're going to do is the next step to finding the slope of your tangent line at the curve is to plug in your points. So anywhere we have an x, we're going to put in -1, and anywhere we have a y, we're going to put in a +1. But be aware, this is not a y right here, and neither is this. These are y primes. So we're not going to be replacing those with 1 because those are not y values, those are y prime values. Okay, so let's go ahead and plug some stuff in here. So 3x squared minus 8xy cubed So I'm just going to put blanks everywhere I see an x or a y, but I'm going to leave everything else in there just the way it is. And so for the x's, we're plugging in -1. And for the y's, we're plugging in a +1. And let's just go ahead and simplify this. So this part here becomes 3. This whole thing right here is going to become 8. This whole piece right here, that's going to be 1 times -4 is -4y. And then this whole piece right here is going to be 2y prime. And our goal is just to find out what y prime is because that's the slope of our line. So putting these together, we have 11. And putting these together, we have -2y prime. And then we just need to solve for y prime using some basic algebra here. And we end up with y prime is equal to 11/2. And that's it. And so that would be the slope of our tangent line. So find the derivative and plug in the values that they give you. Question 5. Question 5, they give me this function here. It's another implicit function. Implicit function, in case I wasn't clear in the last question, is anytime you have an equation where the y variable is not already isolated, it's buried inside the equation. So that means we get to do implicit differentiation once again. So here we go. Step 1, I like to start like this. And then I go ahead and find the derivative. So let's start with the easy ones. The derivative of 4y is going to be 4, but we get a y prime because there is a y there. The derivative of 9x is 9. And then when you take the derivative of an exponential function, you get the same thing again. But we do need to multiply it by the derivative of the inside, which is the derivative of this up here. So the derivative of the 3x is 3, and the derivative of the -2y is -2y prime. Okay. Now I'm going to go ahead and distribute this e really quick. Now the next thing we want to do is we want to get everything that has a, I lost my y prime over here. There's supposed to be a y prime there. We want everything that has a y prime to be on one side of the equal sign and everything that doesn't on the other. So what I'm going to do is I'm going to subtract this 9 to the other side, and I'm going to add this expression to the other side. And so if I do that, we will have the following. All right. Now after you separate the y prime expressions from the non-y prime expressions, you're going to factor out of each one of these terms here the y prime. And that will look like this. If I can squish it in there. Yeah, just barely got it in there. All right. Last thing I'm going to do is I just want to divide this to the other side, and we end up with the following. And there's our answer. Y prime is another way of writing dy dx, so that would be our final answer. And just so you guys know, depending on how you choose to get the variables solved for, like for me, I chose to add this to the other side and subtract this, but I could have just as easily moved this one and this one instead. Now, you would still get a correct answer if you did the opposite, but the difference is all the signs would have been opposite if you did that. And that's not wrong, it's just different. So be aware that when you solve these problems, even though you do every step correctly, it's possible that the correct answer in a multiple choice test will look exactly like yours. It'll just have opposite signs. All right, let's go ahead and take a look at question 6. Question 6, the point 3, -2 lies on the curve in the xy plane given by the equation here. And then we're being asked to use the tables, or the values in this table here to find the derivative. So to find the derivative, we're going to go ahead and just begin by taking the derivative. All right, so we're going to have a product rule here, it looks like, and another product rule. Ew. I know, we don't like product rule, but we're going to have it. All right, so I'm going to take the derivative of this guy here, and that's a product. I've got f of x being multiplied by y. So that's going to give me blank times blank plus blank times blank for my first product rule. And then plus, and we'll take another product rule here, blank times blank plus blank times blank. And then finally we have equals for the derivative of 4, which is just 0. All right, so let's go ahead and do these product rule derivatives here. So we have f prime times y, and then f times y prime. All right, and then we're going to repeat that with this one here now. We're going to have g prime. Now that one has a y inside of it, so I'm going to put a y prime there. And then x, and then gy times the derivative of x is just 1, so we'll put 1 there. All right, now we're ready to start plugging some stuff in there. So let's see. I'm going to leave blanks everywhere. I'm not going to put a blank where the y prime is, because remember, we're plugging in these numbers up here. That's an x and a y. That's not a y prime, so we're not going to plug them in for y primes. But we will plug them in for x's and y's. Don't really need the times 1, so I'm just going to get rid of that. All right, so x is 3, so that goes there, there, and there. And then y is -2, so that goes there, here, and here. All right, let me clean up my workspace a little bit here. So we took the derivative, had to do the product rule. Now this is where the table is going to come in handy, so let's go ahead and take a look at how the table works here. So we have f prime of 3, that's right here. So f prime of 3 equals negative 3. We also have f of 3, that's right here. F of 3 equals 1. We have g of negative 2 right here. That's this guy. And then last but not least, we have this guy, g of negative g. Oh, I did that wrong. Let me back up a little bit. G prime of negative 2 is this guy. So g prime of 2 is negative 5. And then g of negative 2 is negative 3. So now we're just going to start replacing these things with what they equal. So f prime of 3 is negative 3. F of 3 is 1. G prime of negative 2 is 5. And I'm just going to take this 3 and move it closer to the 5 and put the y prime after that. Because it's multiplication, you can rearrange the order, that's fine. And then g of negative 2 is negative 3. All right, getting there. And now we just need to simplify, because our goal here is to find y prime, right? So this is going to be 6 plus y prime plus 15y prime minus 3 equals 0. Let's go ahead and solve for y prime. So the first thing I'm going to do to solve for y prime is combine my like terms. The 6 and the 3 can go together just to make 3. And then the y prime and the 15y prime can go together to make 16y prime. And then from there we can go ahead and just solve for y prime. And then we have our final answer. All right, and there you have it. Question 7. The line is, supposed to be an is, the line is tangent to the curve of f of x at the point 1, negative 2. If g is the inverse of f, find g prime. All right, so you'll find that sometimes they do this, and it makes things a little bit confusing, because we know how to find the derivative of an inverse function. The derivative of inverse function looks like this. And that's the formula I'm going to use. But they want us to use g instead of f inverse. So that just means that we're going to have to change our letters a little bit. So everywhere you see in this formula here, everywhere that you see a f inverse, like here and here, we're going to be replacing those with the letter g, because that's what they want to call the inverse in that case. So we have g prime of x then, which is what we're looking for, is equal to 1 over f prime of g of x. Okay? Now I want to find the inverse of g prime at that point. Now, this point is on the curve of f of x. Okay? And what that means is that f of 1 equals negative 2, which means that the inverse is f inverse of negative 2 equals 1. But remember, we're not using f inverse, we're using g. So g of negative 2 equals 1 is how we're going to go with it. So what we're going to do here is, since we know stuff about g of negative 2, that's what we're plugging in for the inside here. All right, and that would be as far as we can go with this one, I guess. I guess we can go a little bit further, though. Let me think here. Oh, no, yeah, we can go farther. So let's keep going. And now I don't know how far your problem goes, but I'm just going to keep going until I get to the simplest answer here. So g inverse of 2 is 1, so I can replace this with 1. Now this is basically asking me, what is f prime of 1? In other words, what is the slope of the f function at 1? Well, that's why they gave me this tangent line here. The tangent line is the slope of the function at that point. So what is the slope? Well, it looks like it goes over 2 to the right and then up 4. So my rise over run is 2. So this ends up being 1/2. There we go. There we got it. So what did we do here? So once again, when it comes to inverse functions, they're always going to give you a point, and that tells you what f is, which you can deduce what the inverse will be because it's just reversed. Then you write out your formula, plug your stuff in, and find what you can. Now the tricky part on this one was figuring out what f prime of 1 is, and you could do that by looking at the graph and just doing your rise over run. Okay. Another tricky part of this, and this is honestly how they do it usually, is instead of saying f inverse, they say g is the inverse. So you just go through and you replace all the f inverse symbols with a g. But it's the same thing. All right, let's go ahead and take a look at question 8. Where did question 8 go? Just a second. All right, so here's number 8. Okay, so first of all, notice that they tell us that f of 2 equals 11, right? So what does that mean about f inverse? F inverse would be f inverse of 11 equals 2. And let's also remember that instead of using f inverse, we're using g, which is the same thing. Okay. Now we want to write our formula for the derivative of an inverse. Which is this. But once again, we're not going to be using f inverse, right? We're going to be using g. And so it looks more like this. Now, we want to find g prime of, I should have put here, just a minute, g prime of 11, provided that g is the inverse of f. So now I want to plug in that 11 there. All right. So now let's find g of 11. Well, we see here that g of 11 is 2. And so now we just need to find the derivative of f at 2. So we're going to find the derivative of this function here, which is 4x plus 4. And then we're going to go ahead and plug in the 2. And we end up with 12. And so g prime of 11 is equal to 1 over 12. And there it is. So that's an inverse question that involves an equation. I think we're going to do, I was supposed to say question 8. Sorry, I had to make this slide up at the last second. I actually left it off. A couple boo-boos there. Let's go ahead and move on to question 9, though. Another inverse question, but this one is for a table. All right. So let's begin. So I want to find g prime of 1. Now remember, g is the inverse of f, and so the formula for that is going to be f prime of g of 1. Okay. Now, if g of 1 equals blank, that means that f of blank equals 1. So which value of x up here has an f value of 1? Well, here's where f equals 1, and there's the x value that goes with it. And so the blank is 5. So f of 5 is equal to 1, which means that g of 1 is equal to 5. And so we have 1 over f prime of 5. And f prime of 5 is apparently negative 2. So we have negative 1/2. All right, so I think the hard part on this one is recognizing this, starting off with a blank and then reversing that blank and then using the table to find the correct thing to fill in the blank. Okay, All right, let's go ahead and take a look at question 10. Now, for this one, you just have a basic derivative of an arc-trig function. So I'm just going to say, look at the derivative rules for arc-trig functions. It should be in your notes for the notes that we took this weekend. Okay. Same thing for 11. And we're going to be skipping question 12, which the answer is A. Question 13. Just want to make sure that you guys know what the product rule is there. The product rule can be applied anytime you have two functions that are being multiplied together. Okay, so keep that in mind. You have to find which function is a product rule problem, and so you're just looking for the one that has two functions being multiplied together. All right, so for number 14. For this problem, there are answers that could use implicit differentiation, but only one of them requires it because the other option can be written in explicit form quite easily and would not require implicit differentiation. So what do I mean by that? Well, let me show you an example here. If I gave you guys this, then that's, you could do implicit differentiation with that. It wouldn't be a hard thing. You would just have to subtract actually, all you'd have to do is move the 5x to the other side. And now it's an explicit function, and so you could just do a derivative like normal, okay? But there are some functions where you would not be able to do that. Like if I gave you guys something like this, tangent of x plus y minus, plus 3x minus y equals, let's just say 4. You're not going to be able to get the y by itself. So that one is hopelessly implicit. There's no way you're ever going to get this y combined with this y. It's just not going to happen. And so in that case, you have to use implicit differentiation for this one. But if you can just get the y by itself at the very beginning, then technically you don't need implicit differentiation. So you got to pay attention to the wording here carefully, even though on your problem they are offering multiple options that can use implicit differentiation. You're looking for the one where you have to use implicit differentiation because you can't get the y by itself. All right, let's take a look at our last one. My bad, this is not the last one. We have a couple more after this. We go up to 18 today. All right, so you're going to do a quotient rule anytime you have a polynomial over a polynomial. So like something like this, for instance, would be a great quotient rule problem. Now technically, this could be a quotient rule. But once again, this question is asking you, kind of like on our last one we did, it's not asking you, can you use the quotient rule? It's asking you, when would that be the best option? On this case, I would not recommend the quotient rule. For that one, I would recommend just moving it up to the top and changing it like that, and then just doing the power rule. Or here's another situation. If you have x plus 2 over x, once again, you could do the quotient rule, but you could also just split the numerator up and have something a little bit easier to find the derivative of, okay, without doing the quotient rule. So there's problems where you kind of are stuck with the quotient rule, and then there's problems where you could kind of mess with it and you don't have to do the quotient rule. And the quotient rule is a big, long, messy rule. It makes a lot of operations and they're really hard to simplify. So if you can avoid the quotient rule in these circumstances, then go ahead and do that, But there are some problems like this one where you just have to do it. And so that's what they're asking. They're asking you once again to find the one where you have to do the quotient rule. All right, let's go ahead and take a look at question 16. They're asking me to do this. Now, what does that mean? That means they want me to find the third derivative, okay? So I'm going to start by changing this to an x to the 1/2 power. Now I'm going to find my first derivative, which is going to be 1 over 2, x to the -1/2. Now I'm going to find my second derivative. Multiply that half times that half, and you get -1/4. And then subtract 1 from this again, and you get -3/2. And then one more time will get me what they're asking for, the third derivative. So multiply the power times the front, and you get +3/6 x to the -5/2. Now that can be reduced. The 3/6 is 1/2. And you can put the 5/2 in the bottom like that. Okay, so that's one way that you could simplify that expression. But the point is just find the derivative 3 times, right? So this one's really just testing your ability to do derivatives as well as your understanding of derivative notation. Let's go ahead and take a look at question 17. The figure shows the graph of f prime. So it's really important to recognize that we're not looking at a graph of f, we're looking at a graph of f prime. At which of the four indicated points is f double prime the greatest? Well, f double prime is the slope of f prime. So if f double prime is the slope of f prime, they're basically asking me where is the slope the greatest? Well, as you guys know, you have negative slopes, you have zero slopes, and you have positive slopes. Negative slopes are the least, positive slopes are the greatest, right? And so let's take a look here. So at this point we have a negative slope because the graph is moving in a downward direction. So that's probably not going to be the greatest one. Here, that's a minimum point on there, so that has a slope of 0. So that's probably not the greatest slope either. Now here we have a positive slope, and here we do as well. And so now the question you may be asking is, well, if they're both positive, how can we tell which one is greatest? Well, it's greatest if the slope is the most steep, because the more steep the slope is, the greater it is. So A is going to be steeper than B, because B is still curving in an upward direction, and A is getting really straight. So I would say that A is steeper. And so I would say it's at point A where we have the greatest slope. All right. Let's go ahead and take a look at our last one here. This one is saying let y equals f of x be a twice differentiable function. That just means you could take the derivative twice, such that f of 1 equals -1. And here's my first derivative. They're asking me to find the second derivative at x equals 1. Now just so you know, if x equals 1, that means y equals -1, because they told me that right here. That's important to pay attention to. All right, well, if I want to find the second derivative, I just need to find the derivative of my first derivative. So in other words, I need to find the derivative of this thing here. So let's get down to business here. So first of all, I'm going to rewrite this as a half power. Now to find the derivative, I'm going to take this and multiply it to the front, which is going to make it 1. And then I'm going to subtract 1 from that power, which gives me -1/2. But this is a chain rule because we have an inside function. So now I need to multiply it by the derivative of the inside. So the derivative of 5x squared is 10x. And the derivative of 4y cubed is going to be 12y squared. But let's pay attention to the fact that we get a y prime because of that. All right. Now I'm going to rewrite this a little bit. So first of all, this whole thing here, I'm going to put it in the denominator, and this whole thing is going to go in the numerator. And so let's write that out. We have 10x minus 12y squared y prime over 5x squared minus 4y cubed. Now, I can write this as a half power, but it's positive now because I moved it to the denominator. But I also, when you have a half power, that just means square root. So I'm just going to save myself some trouble and just make that a square root now. Okay? All right. So there's our second derivative. So if I want to find the second derivative at x equals 1, I need to find the second derivative. So I've done that. So here's my second derivative. But now they want me to find the second derivative's value at x equals 1. Okay? So to do that, we're going to be plugging our numbers in, right? So for x, we're plugging in 1, and for y, we're plugging in -1. Now, y prime is not y, and it's not x. It's y prime. So don't plug anything in for that yet. All right, let's simplify this a little bit. We have 10 minus, it's actually going to be, no, it'll be minus 12y prime over 5 plus 4 is 9, the square root of 9, and that's just 3, so I'm going to go ahead and just, the square root of 9 is 3, so I'm just going to put that there, save myself a little writing. So there's that. All right, so now what? Well, we need to plug something in for y prime. How can we do that? Well, we have y prime. Y prime is the first derivative, which is right here. So if I take this and I plug in 1 for x and -1 for y, then I can find out what y prime is at that point in time. So this is going to be 2, and this is 9, so it's the square root of 9 is 3, and so you get 6. So my y prime is 6. So we have 10 minus 72 is -62 over 3. And I don't think that reduces, so I think we're done. So there it is. So when you have an implicit function, when you take the second derivative, it's going to have a y prime in it. Okay? And so usually what we do is we replace the y prime with the first derivative that we already have. Okay? So that's that. All right, and that'll do it for today. So hopefully that was helpful, and we'll see you guys in class tomorrow.